we shall discuss about the bond fission and the types. So what is bond fission? A bond is formed by two electrons. When we represent a line between two atoms, it can be two same atoms or two different atoms. So such connection between the two atoms is represented by either a single line or a double line or a triple line. So when there is a single line, we call it as a single bond. When there are two lines, we call it as a double bond. When there are three lines beside two atoms, then it is a triple bond. So a single line indicates two electrons between two atoms. So generally the bonds can be covalent or ionic. We shall discuss about mainly the covalent bond in this bond fission types. So covalent bond, in brief, it is formed by sharing of electrons. So sharing of electrons is possible between the two elements which have same electronegativity or very less difference in electronegativity. So such molecules, such atoms can form a sharing of electron covalent bond and result in the formation of single, double or triple bond. So here we are to discuss about the fission, that is the breakage of the covalent bond, and how many types of breakages are present. The first type is the homolytic cleavage or homolytic fission. First is homolytic fission and the second will be heterolytic fission. So by the name we can infer that homo is same and hetero part is different. Homo is same, hetero is different, lysis is the breakage or fission or the cleavage. So when the atoms, same atoms are forming bonds, for example X is an element and another X is also a same element, when they form bond by sharing of equal electrons, the bond that is formed between these two is broken down, then that would result in the formation of free radicals. That means the electrons that are being shared between X and X are equally shared again after being cleaved. This is indicated by a one-headed arrow, or we can call it as fish hook arrow. So it is represented by this arrow which indicates equal number of electrons are distributed among two atoms. Since a bond contains two electrons, one electron goes with one X, the other electron goes with the other atom. These are now considered to be the free radicals. They are the free radicals that are formed. If you consider the second case, that is heterolytic fission, in heterolytic fission we observe two different atoms are present. So these two different atoms will have difference in their electronegativity. Usually the first element will have less electronegativity, that means more electropositive, and the second element will have more electronegativity. So what is electronegativity? It is the tendency to pull the electrons that are between these two atoms more towards it. So since X is less electronegative, it has less capacity to pull the electrons. Since Y is more electronegative, it has the more capacity to pull both of these electrons towards it. So Y will experience more negative charge. So we get X with the partial positive charge and Y with the partial negative charge. Since X is having the positive charge, we call it by the name called cation, and Y is with the negative charge, we give it the name called anion. In case of homolytic fission, we get free radicals. In case of heterolytic fission, we get cation and anion. Generally, ions are formed. So if we look at the examples, we can see Cl2 molecule, Br2 molecule, H2 molecule. These require the sunlight or H nu because the bond that exists between the homolytic molecules, homomolecules, is the stronger bond. So to form the free radicals, it needs a lot of energy, so we require sunlight. In case of heterolytic fission, the energy required is less compared to that of the homolytic fission. So any homomolecules can undergo homolytic fission, any heteromolecule, provided the molecule has to be a covalent molecule. In this case we considered ionic, but this has to be covalent molecule. So due to the difference in electronegativity, we can say carbon is negative, hydrogen is positive, or we can consider CCl, where C will be positive and Cl will be negative. This way heterolytic fission can be possible.